Working now. And I'm going to talk about the Slurm Job scheduler and how to use Matlab in the terminal. I have logged into ASP.C2N, UPPMAX, and to Cosmos from LUNARC, since people mostly are from there. Most people are. This line here will show up now and then. It's because it's a warning to people that it will reboot tomorrow morning. You can ignore it. Just remember to be logged out before that time when it will be logged out. Because it's rebooting due to maintenance. Anyway, so I will first talk a little bit about what is a batch job, how to make batch jobs for Matlab, and how to configure the cluster for Matlab. And the part about configuring the cluster is something that can be done either in the GUI or in the terminal. Though in the GUI there's another way to configure it as well, but that will be covered in the next session. So hopefully this will help you understand and use the Slurm scheduler and how to configure the cluster, how to start Matlab batch jobs from the command line, and there will be examples to try. Here, these computer allocations, the project IDs will be relevant. When I mention project ID, I mean these numbers here, strings, and they are valid for this course and for a couple of weeks more, I believe. So you will have time to test things out at the systems that you have access. And later you will just replace it with your own project IDs, your projects. So here it is these two here on UPPMAX and Cosmos. Again, there is a storage space for the workshop, and I believe if you're at the ASP.C2N or one of the others four here, you have downloaded the tarball. And if not, please say so in the Q&A document, then one of my colleagues will help you, because the tarball contains exercises. If you are on Cosmos, then you will use your home directory, since it's bigger than the home directories at the other centers. It's about 100 gigabytes instead of 25. It's quite some difference. And then there's one thing to say, that's any longer resource-intensive or parallel jobs must be run through a batch script. And Rebecca has mentioned several times that you shouldn't hog the login node with the huge and heavy jobs, because it slows it down for everyone. And the batch system at UPPMAX, ASP.C2N, LUNARC, NSC, PDC, and also most other centers in Sweden and elsewhere is called Slurm. Slurm is a very popular open source batch scheduler. And it has three key functions. It keeps track of available system resources. That is, it knows about which nodes are there, what amount of memory is there, how many CPU cores, how many nodes that have GPUs, what type, and so on and so forth. It enforces a local system resource usage and job scheduling policies, which vary somewhat between centers. And it manages a job queue, distributing work across resources according to policies. So when you submit a job, it goes into the queue. And if there is a free slot on the system, on the resources that you asked for, your job will start running. If there is not, it will get a priority, and then it will start running when the priority is highest among those that has that asks for resources that fit into an available slot. And it can vary. If you have run a lot in your project, then your priority goes down, at least at ASP.C2N. And then over time it goes up again as other people are running more in their projects. So jobs have priorities, and you can see those when you are doing the command SQ. If you attended the R part, you learned that you ask for compute resources via the sbatch command. And in order to run a batch job, you need to create and submit a Slurm submit file. And this submit file is named also batch submit file, batch script, job script. You will find any of these names when you are Googling it. They all mean the same thing. There's guides and documentation at these places here for each of the centers. And Matlab itself works well with Slurm. And so there are several ways to run the jobs. You can use the job scheduler batch in the Matlab desktop. In the graphical interface, both works, and that is the recommended use at most centers. You can start a parpool with a predefined cluster. This gives more interactivity, but it does not work everywhere. I'm not sure what the status is at SPC2N right now. There has been problems with it before. It supposedly works at Dardel, but when I test it, it immediately throws me out of the allocation. So I'm guessing there's some issue. You can use it also through writing a batch script, just like for any other software, and submit the job with the sbatch command from Slurm. And this is useful for those who have want to run long jobs and you don't need to modify the code in the meantime. That all of these ways of using it are done by different people. So let's look at these ways of submitting jobs. So some useful commands that is important to know is if you are submitting a job on the command line, then you use sbatch and the name of your job script. The job script, you can name anything, and you don't need to give it any suffix either. .sh or .batch or .sbatch are common choices, conventions. It's not necessary, it's just a way of making it easier for you to find them in your directory when you're looking for the files. To get a list of your jobs, you can use the command sq -me or sq -u and your username, both works. To check on a specific job, you do scontrol show job and the job ID. The job ID you get when you submit a job or when you use sq to get a list of your jobs. You can delete a specific job with scancel and the job ID, or all your jobs with scancel -u and your username. To get useful info, you can use the sacct command. It will give a very wide output, which is why it is typed, that is this line here, to another command, which is less, and -S, that makes it sideways scrollable with the arrow keys. It will give output that contains info about how much memory was used and other things. There are also other ways of seeing this. There are, for instance, at UPPMAX, you can get a URL to a page with info about a job. If you run job usage and then the job ID. Some of the other centers have similar commands, which is not listed here, but needs to be at some point. So the very first time you want to submit a job to the Slurm queue, you need to configure Matlab. And before I do that, I think actually I will quickly show you how these batch commands work. And to do so, I will just grab a random example here. I have a serial example for UPPMAX here. We'll look more at it, but I'm just going to submit it just to show you how it happens when you submit a job. So I do sbatch, and then I can do SQ, -1 to me, and then it shows here the job ID is here, the same as I got here. The partition it runs in will vary depending on what nodes it ends on, and it's different at different centers. But here it tells me it's running on the CPU nodes of the Skylark type. This is the name of the job script. You can give that in your job script. Otherwise, it will just use the name of the job script. The user, and then the status, which could be CF for configuring before it starts, R for running, CD for completing, PD at the very beginning for pending. Then how long it has run, how many nodes or rather cores, and on which node it is running. So let's see, it has now finished. And when it does so, if you don't name the file, it will be named slurm-jobid.out. This example I had here had created specifically named output files. And we will look slightly about that later, but I can just show you this one file here. So this is the commands to name the error and output file specifically, and we'll mention this later, but right now I'll just say that here is where you ask for resources and give your project ID. Here is where you get tell it which modules to use, and then comes the actual running, where you give commands to the program that you are running. Okay, let's continue with the first time configuration of Matlab. And there's a list here about how to configure it for each of the centers that you can go to, but otherwise we're going to go through it here a little bit. So to be able to use Matlab and 2019B and later, there was a change there. Together with the batch system, it needs to be configured to use a cluster profile. And that needs to be done once for each cluster and each version of Matlab. To do it, if you're running Matlab 2023A and 2023B, you have to run it twice. Once after loading each of them, but then not again. And yes, it's done after loading Matlab. And that provides a set of default specifications for batch and parallel jobs. It's a cluster profile, is what it's called, and it is used by Matlab to get information about the cluster, so it knows how to run on this cluster, what exists there, how to talk with it. And they can be changed or added to at runtime, and you can have more profiles for a single release. And I don't think anyone does that, but it's possible. And as I said, to configure the cluster, you load Matlab, and then you run this command here. And it's run a little bit different at each of the centers. At UPPMAX, you run config cluster.sh and then a project ID. At HPC2N and LUNARC, at LUNARC as well, you learn config cluster and project ID, and then choose customers. At HPC2N, you just give config cluster.sh, and at NSC, you need to go into the Matlab and run config cluster. So it is slightly different between the centers. At Dardel, you do not do config cluster. It's already set up. And Dardel is a somewhat more different system than the others. It is also possible to do the cluster config at LUNARC inside of Matlab if you want to, but otherwise you can do them outside. And this is how it looks. I guess I can suggest do it here. So I will do ML Spider Matlab. And then I will load Matlab. I will just take the newest. And then I will start Matlab. No, wait, I need to do the config cluster. I will do the config cluster. So I'm doing that, config cluster.sh. And it is then doing it. And then after a little while, to kick again from Matlab. So it starts Matlab and does the configurations and then exits it again. And as you can see, it's giving some information here about things you need to do. And we will do that in a little while. The same thing can be done at the instance. Let's go. Let's see, I'm guessing we just load it directly. Let's see, yes. So I will load it. And then I will go back here. And then I will check how it is done. And here you see, this is one of the places where you give the project ID. In this example, I'm using the teacher's project ID, so you will use a different one as listed at the top page. Yeah, we'll use that one. Or if you have your own, you can use that, of course. So it's now doing the cluster configuration also. This was and after a little while, it should ask me which cluster I want. Unless that has been changed, because I'm guessing Aurora is retired, is it?
Yes, Aurora has been decommissioned.
Yes, so maybe it's been changed not to ask for it, but we'll see.
Yeah, I'll have to ask if they can get that fixed.
So you pick Cosmos. And after that, everything runs the same way as it did at HPC20. Like that. Good. And as you see here, what it tells you is Matlab is now configured for multi-node parallels. And let's do that, because you will all need to do this. You will need to get this to run. So you are all logged in. So go to your terminal or to your thin link and open a terminal. And then load Matlab and then do config cluster in the way that is suitable for your center. And I believe everyone is LUNARC or HPC2N, or are there any other centers? Well, if there are, it's listed up here. How to do it. So I guess let's take just a couple of minutes. Yeah, Rebecca already, that's how it works at that.
Did you need me to comment on something?
No, I just said that this comment about which MATLAB to load at Darden, you had already commented on how things worked out, so or not.
No, I hadn't mentioned that yet.
I believe you said that you needed to load PDC 2312.
Yes.
Yeah, that is what I was talking about. Okay, I'm going to assume it worked for people. Otherwise, just let it finish in the background, and I will start on this again. So the Matlab terminal interface. Now it's time to try Matlab out on the command line. And as you can see here, when we did the config cluster, it tells us there are some things that needs to be set, and those are job settings. And they need to be set if you want to run jobs on the Matlab on a cluster. So, and there is the part cluster, there is the additional properties and the batch. And we will look at all of those now and how to start a job from within Matlab. And these things can all be done in the exact same way in the GUI, but there are advantages also to do it on the shell, in the terminal, because it is a lot more lightweight, and you can use it if you have just a regular SSH connection, and you don't really want to wait for a GUI, which can take a long time to start sometimes, especially over a slow connection or over an SSH-X connection. So to start Matlab on the command line without running the GUI, you load the Matlab version and you do this line here. It differs a little bit between centers, how many of these are needed, but no harm comes from actually using all these on each of the centers. At least I haven't seen any difference. So let's take this command here, and I will use that to start Matlab at SPC2N and at the LUNARC. And again, as Rebecca mentioned, -single comp thread has to be used in order to stop Matlab from using more than one thread and eating up stuff on the login mode. So let's do that. Start Matlab. It will take a little while, not too long. That is already up here. And of course, everything works the same as it would in the GUI when it comes to working in it. As this example here, which select avoid otherwise. Exactly the same way as it is. So that is fine. You can use it for that, for a very lightweight way of doing minor things in Matlab. But you can, of course, also do more advanced things, just like you would do on the GUI. But here we are going to look at the job settings first. And first, we need to do C equals part cluster. And it also matters which center you are at. And at UPPMAX and PDC, you just do C equals part cluster. And at the others, you would do C equals part cluster and then the name of the cluster. This actually is not always true, at least I believe you can just do C equals park cluster at SPC2N as well. But let's see. Like this. Because it already knows it's Kepler-Kaiser from going to the cluster configuration level. Note that if you're on UPPMAX, you also need to add this one here, the additional properties, to tell it that the processors per node should be 20. At PDC, you don't set additional properties. They are different in this way as well. You work in an interactive session instead, and there is where you set these values, because it's used to set project IDs and how long to run and what resources to run on, and those are instead done by starting an interactive session and then starting Matlab at PDC. So if any of you is working there, you can, for instance, ask for a full node like that, or for less than a full node like this. Then, as Rebecca said, SSH into it, at -X if you want the GUI, otherwise just regular SSH. Load Matlab, start it like you did here. Though you don't then need the -single-comp procs, because it's already you who has all those resources. But stepping aside from that, let's set the job settings. So, at SPC2N, which is where I'm here, I will do some additional properties. If you start typing a command, you can hit tab and it will autocomplete if there is only one option. So here it autocompletes all the way up to additional properties, and then I will try to get account name, yes. And here is where I put my project ID. So I will say SPC2N 2025 062. That. And then semicolon. And then let's also set the wall time. That is the time I expect it will take for my job to run. I am going to just go with 15 minutes instead here, because I'm not going to run anything heavy. This. And then I'm going to save the protocol. If I want to see what I have set, I could do c.additional properties and nothing else. And then it lists the content here. Another thing is, if I want to reset something, if I want to delete it, then I would, for instance, if I wanted to delete what I set for the wall time, I will do like this. Properties, wall time, once, and then just, sorry, 2 apostrophes, no content in it, so 0. And then you can see it's now being reset. Let's set it again. That. And I'll make sure I set it. Now the properties here are set. And let's do the same thing. LUNARC. And you can see here there is some mention of what you use for cluster. At SPC2N is Kepler-Kaiser. At UPPMAX it's nothing, it's just our cluster. At LUNARC it's Cosmos R2023B. It is at NSC, it is tetralit. At PDC you don't do this setting, but you do the c.park cluster, nothing else. And here again the project IDs. So this, let's see, I think we are going to do a typo on data. Yes. So I think it's a good idea that you now actually go and do these few additional properties just to try it out. So go ahead and go in, start Matlab after you loaded it. It's already loaded, I'm guessing, because you did config cluster. So start it with this this one here, minus single comp thread, minus no display, no splash, no desktop. And then do C equals park cluster, and then dependent on where you are, you write the cluster. And then you do additional properties for the account name and for the wall time, and then save the profile. And let's take 2 minutes for that as well. I'll go ahead and do the same thing. LUNARC. And I am using the teacher's project. You are using your own project here instead. So this for LUNARC, and this if you're at UPPMAX, and otherwise it is the transfer. For the wall time, it is hours, minutes, and seconds. And you can at most ask for the number of hours in a week, 168. I'm just asking for 15 minutes. Okay, let's continue. Now we have set the job settings, at least some of them. And let's now try and start the job from within Matlab's terminal interface. And you do that again the same way as you could also do it in the GUI. It will, as default, use the cluster profile that we have just set up. And if you log out of Matlab and into it again, you do need to say C equals park cluster. But then that is to get a handle for the park for this cluster, but it will still know the properties it has set but you still don't need to do C equals part cluster each time you start up Matlab. So you could create job equals batch and then some script that you have, get it to run, and it will not block Matlab. You can continue working while the computations take place, and this submits it. If you want to block it, you can also use wait and job. And the job is this here. By default, Matlab saves the command window output from the batch job to a diary of the job. To retrieve it, you use the diary function. If you're in the GUI, it can also just list it in one of the windows. After the job finishes, fetch the results by using the load function or with job fetch outputs. If you need the job ID, you can run sq --me on the command line outside of Matlab. So if you open another window on the same cluster, you could do that. Then you could get the job ID. If you want the Matlab job ID, you can say ID equals job.id. Of course, you don't need to call it job, you can call it J or something else. To see if the job is running inside Matlab, then you do job.state. So let's look at a more advanced example. I'll say that for how you would run a serial batch job from inside Matlab. So you get a handle to the cluster, always, C equals par cluster. And then here in the next here, my FCN, in this example here, is either a command or a serial Matlab program, depending. And N is the number of output arguments that you expect from the evaluated function. And then you have a number of input arguments. And you could do that and then submit the job. You could then query the state of the job. And it should, of course, have either been J or job here. If the state of the job is finished, you fetch the results. And if you don't need the results more, you can delete the job. If you're running a lot of jobs, or if you want to quit Matlab and restart it, you can retrieve the list of jobs with jobs equal seeded jobs. And you can also retrieve outputs of the second job or third or whatever. So let's do a type along example. In the exercises that you got from the table, there is a Matlab file that is called add2.m. It just adds two numbers. You can pick any numbers you want, of course. In this example, I'm just using 1 and 2, and I'm also just going to try and draw it to the last. So I will call it job. And then let's see that batch. And then I have this program. It's called add2. So I write that. And then I expect one output. And then I have two input. And let's just write something. And then we end this. It is slow today. It is submitting a batch job, so it is likely waiting for it to start. It started now. And when it does, it will tell you which submit arguments it used. And you can see here it used the account name that we gave it. It used the time we gave it. And then it also set tasks, a number of tasks to 1 and CPUs per task to 1, because that was the default. I did not set those. I could have done that as well. It's also possible to say what type of node you're running on. And then you get some properties for the job, sort of like what you got with SQ, just a little bit different. And then you can do job dot state and see how it's going. And it's already finished. So let's go ahead and fetch the output. And the answer was 271, which was probably correct. Let's see what was I gave it. Yep. Okay. So that is one way of running a simple serial Matlab program when you start this batch job from inside Matlab. And it did run on it did run on compute nodes. Sorry. I'm just going to start another connection to Brydsö just to run SQ while this is run. Okay. This, then I'm going to start this job again. See if it runs long enough for me to type. It did, as you can see here now. That is actually running, and it's this job here that it named itself here. It has this Matlab ID, so that is the name it got. And it's running, and you can see where it's running. So that's nice. I'm guessing it's finished. And I got the output, which was the same. Okay. This you should test. I think I'm going to continue talking about the parallel, and then you can try both of them because we don't have that much time. So if you want to run a parallel job, it's almost the same as running a serial job. It's just that now we also need to give a Matlab pool to use. And of course, your Matlab code needs to be parallelized. So let's pick an example. Again, you have some job here. It's sent with the batch. And you have the name of it. You have the number of output you expect. You have the inputs. And then you also telling it you have a pool. You want to make a pool of workers. And then you tell how many workers. So to run a simple Matlab script, and I have one that's called parallel example.m. I would like to give the input 16 to it. I would like to create 4 workers, and I expect one output. Here I just use J instead of job. It's just to show you can name it as you want. I will try to run this again. And I guess I will try it on the LUNARC. This time, just be different. Example. And one output. And I want to have 16 as the input. That's just one input. Then I am creating a pool of workers. I want 4 workers. Let's try this. And I wrote 3 workers because I didn't see what I was typing. I wasn't looking. Anyway, it doesn't matter that much. So it's starting a pool of 3 workers instead of 4. It will take a little time because it's now sits in the queue. I can type the same. It started. So I did not set the count. Yes, I did.
The 2025.
Yeah, it's yeah, that was why. Yep, I forgot that. The teacher account comes from last year. Yep. This explains things. Yeah. And now we're happy. Okay, and as you can see here, the number of tasks are 5, because yes, you have 4 workers, but you also have 1 master, or what we should call it. And otherwise, it asks for these things here, which were also set. And again, now the account name and the time, and the rest of the values are default values that you could change, but which look like this. So let's see if it's still running. It's finished. See? And I'm going to assume that was the correct output because I've seen the similar one before. Yeah. It actually gives this value at customers and this value at HPC2N, and I don't know why, because I run it before and it also gave something like that. Let's see what it does here. I'm just going to go and look at the program. Ah, it's also finding time. Okay, then that explains why it will take different time. Okay, sure. Then always says it should be. Yeah, I'm fetching it from this one. Okay, it took about the same time. And now there are 2 examples for you to run. There's a serial one where you don't create a pool, and then there's a parallel one where you create a pool. And you can use add to for the serial and parallel example for the parallel one. And I definitely think you should try and run these. So try and start them up, and let's take until 12 o'clock and try that. After that, I need to talk about Matlab batch jobs, and I think actually we should probably take lunch break before I do that, because otherwise it will probably take me 10-15 minutes, because I also wanted to actually try and run that. So why don't we do lunch break now, and you can test the serial Matlab example and the parallel Matlab example, and then take lunch, and then come back at 1 o'clock, and then I will finish the section about Matlab batch jobs as well, and then after that we go to the GUI. So I just talked about how to use batch jobs or submit batch jobs from inside of Matlab, but it's also possible to create a Matlab batch scripts, just like you could for many other programs. So we will try and create some batch scripts here, and I will put Matlab. And I will try to show you how to use batch scripts to run serial parallel jobs on Matlab. And yeah, there's also PowerPool, which I haven't mentioned much, but some programs can take advantage of a power pool, and that means that if you are inside Matlab and starts a power pool with some number of workers, like power pool for 16 workers or something, and then have set the additional properties, then you can start some types of Matlab's jobs that will take advantage of this power pool. And that works at least at UPPMAX Cosmos and Kepler-Kaiser. It's also supposed to work at Dardel. But as I said earlier, it crashes for me as soon as I attempt it, so I need to debug that. I haven't tested it and tested it. So this is an example of a serial batch job. So these batch scripts, they are submitted outside of Matlab. So let's exit Matlab here. And in the exercises section that you downloaded, these are the batch scripts, the one that I have marked with .sh. Just to remind you, you don't need to call them that, but it is an easier way to find them. And because there are differences between the centers, mainly the accounts, the project IDs, I have created one for each of these computers. Sorry, there are some perfume in the corridor and I'm very much allergic. Okay, so these are the examples here for a serial Matlab job. And the first line you notice is always going to be there in a batch script. And that is telling it to run in the bash shell. You don't need to worry about that. It's just because that is the only one that's fully compatible with the batch system. So you should just put it there. And then you always need to give the project ID so it knows which location to run in. And at UPPMAX, it's this one, and you can see you just replace it. And it's a serial job. We're asking for 1 core. And here, 30 minutes. It's probably not going to be needed for this example. So Monte Carlo script, it's not very long. It maybe 5-10 minutes would be enough. And you would change it to that so it starts faster. And here you see that you can name the output and error files specifically. If you don't, they will both go the output to a file called slurm minus the job ID.out, unless the program will run creates outputs itself. A good thing to always include in these error and output files is %j. It's an environment variable which contains the job ID, and this means new versions will be created for each run. Whereas if you just name it my output, it will be overwritten with the next one. And then clean the environment. This is something that's recommended at some centers and not at others. Rebecca touched on the danger at the GDC, so this will actually, you would need to do the module restore the collection you created here if you are on PDC, if you do the purge. Then afterwards, you always need to load the module, and here Matlab, and then comes executing the Matlab program. Since a batch script is not interactive, you need to give any parameters to it, like I do here. And then you can just submit it. And if you look at different ones, you can see the difference between the centers is very minimal. It's mainly this line here, the project ID, and this line here, which is the name of the module. And when you change between systems, these you will find these are the main differences. You can either download this file or you can find it in the exercises directory. Indeed, it is here. It is this, it should be here and there. Like this. It will be in the Matlab directory that was created when you untarget the target. And let's try and go ahead and submit it. And you could do the same. So go to this directory and then just submit this script here. If you type tab after you've written the first letters, then it will suggest autocomplete it if there's nothing else that matches it. So that's an easy way of writing the whole name. And it did complain. Let's look at it and see what happened to it. And what happened was that I did not hit the batch script. But the batch script is here for Kepler-Kaiser. And for Cosmos, it's this one. But I can hit the diagram. So instead, there's batch. And then take the batch script for the specific system. And you see, then it submits it. And here you get the job ID. And I will do the same thing at Cosmos. And we can try and do SQ -me, and it already ran. So I will submit it again a couple times. And you will see it's running. Let's do the same thing here. And here you can now see I submitted it several times, and one of them is running, and it has a node assigned to it. Compute node number 15. The other three here are pending, and you can see here now another one is running and only one is still pending. And it created output files for each one. And the same thing will have happened here at SPC2. You can use Nano to look in these files. And let's see, 3, 4, 8. And if you hit tab one more time, it tells you which possible completions will be there. So we'll put here. And then you get this output here. And the output was that it took about 3 seconds to run. And this was Nano, so I exit with, when you use Nano, if you haven't used it before, use Nano and the file name, or just Nano to create a file. And to exit it, you would hit a control, that is this hat, that means hold down control, and then type X. Then it asks, do you want to save it? And if you say yes, it will ask if you want to keep the name or give it a new name. If you say no or N, then it just closes. And if there were errors, in this case, they would go to the .err file. In general, if you don't include these lines here to name the output an error file, as I said, they go to slurm -jobid.out, both of them. Let's continue. For parallel batch script, the main thing here is that now you will also tell it more nodes or more tasks, because it's a parallel job, so it needs to be able to run more threads, and then it's always a good idea to actually give each thread a core to run on. And it's also possible in the Matlab, you can simply use this inside of the Matlab code. So this is what you would put inside of the Matlab code, among other things. And let's go ahead and open the sample. And you can see this is a very simple example. The only parallelization here is that I'm using par4 instead of 4. And that actually parallelizes it. And that means that we can run that. And here I'm suggesting that you make a batch script for running it. But let's just instead just use the one that is already created, and then you can try and run that. You don't necessarily need these 2 lines here, but it is good because Matlab can misbehave sometimes. So this way you are sure it's not creating extra threads. So I'm just going to submit this file, and you can see it's this one at Kepler-Kaiser. There's a similar one which in the other sentence. So let's submit it. Pending there. And here it's running. So I will let it run while I will finish this. And you can also just submit it and see what happens. So the last part is what if you wanted to use GPUs. And you can do that inside of Matlab, and you can do it in a batch job. I'm just going to cover the batch job first, and then I will just open up Matlab again quickly. So if it's in a batch job, you could write a batch script that does this. And there are examples here also for that. Use here, GPU Matlab script. Or you can do as shown here in this example from UPPMAX. You can use the interactive or SLR. And then you give much of the same information to the batch system as you would in a batch script. You tell it the project ID, how many cores, and in this case you want to run on Snowy because that is the one that had GPUs at UPPMAX. And you tell it I want a GPU and hold on. If you instead wanted to do it at HPC2N, then this is inside of Matlab. Then it's important to notice that HPC2N has many different types of node and GPU nodes and different types of how many GPUs cards are on each of these GPUs. So that is something you have to pay attention to. So either you don't say which type of GPU and just say no more than 2, because that will fit everyone. Or if you want more, then you have to also tell it what type of card you want and pick one of those that has more. And LUNARC, you just say how many GPUs. And the same thing like you'll see and at PDC with the caveat that there you always need to start an interactive session and run Matlab on that node, simply because you actually also need to SSH to it. So that should have been listed here. Because at PDC you don't set the additional properties, you instead start an interactive session where those things are already set. And yeah, if you are doing this as a batch script, you put these same commands here that you otherwise put on the interactive line. Those you put inside here. You tell it it's snowing, you tell it how many GPUs. And you can try and take a look at each of these here just to see how they look. But let's try and start Matlab again. And we can do the same. So start up Matlab again. Remember, single comp thread, no display, no splash, no desktop. If you push the arrow up a number of times, you will go through the history of the commands you have given. So I am now inside of Matlab again. So I'm doing C equals part cluster to get a handle. It takes a moment, and then I do C additional properties, and you can see it remembers what you had set. And now I would like to also tell it that I want to use GPUs. And so I will go and see how do I do that at the SPC2N. I say C.additional properties, and then I say GPUs per node, for instance. And then I tell it how many I want. And then remember, if you ask for just 2, then it can work with any of the GPUs. And now you can see it's here. And you can use constraints or GPU card to tell it that you want a specific one, but in this case it's not necessary. But do pay attention to one thing now, because now we are saving it. And that means that it's in your profile. And when you now close Matlab and you start it up again, and next time you just want to use CPUs, then you need to unset GPUs per node, because otherwise it will still be set. So you do that the same way I showed you earlier, with just giving it an empty string like that. And then it's gone again. And at LUNARC, you do the same thing. Also, this one command here is needed everywhere. It's just that at some places you also need to set at SPC2N, for instance, you can have to set what type of GPU. But otherwise, it is just giving how many GPUs you want, and then saving the profile, and then remembering to unset it if you later want to run on just CPUs. So I'm going to end this and say that just to sum up, Slurm scheduler handles allocations to the calculation or compute nodes. Batch jobs, they can run without, they do run without interaction from the user. Batch scripts has one part Slurm parameters that describes allocation and resources, and a second part that describes actual work, including loading modules and whatever Matlab script you are telling it to run. And you can run Matlab as a batch job through a batch script or from inside of Matlab. And it's the same whether it's a shell or a GUI. And remember to include possible input arguments to Matlab scripts if it's a batch script. And you need to configure Matlab before submitting jobs, except if you're on Dowdell, where you instead set it in the interactive job. So I think that's the important parts.